In this lesson, we'll continue to use the viscosity attributes to set up a scene where we can cut dough. So I already have a couple of pieces of geometry here inside this scene. Let's take a look and see what we've got. I've got a ground plane, just a standard default ground plane. And because of that, I have my Autodop network. I have a knife that's already been turned into a static object with an animation on it. Let's look at the animation. Okay, so it's just one simple cut. And what we're looking to do is to come down on top of this third piece of geometry, which is this tube I've labeled dough. So we're going to imagine that it's like biscuit dough, like a can of biscuit dough that you've just opened. And you want to cut it in half with a knife. Well, one way to do that is to use viscosity. And we've already looked at the viscosity attribute and a little bit about how to use it. So let's go ahead and see how to use it in this scenario. Let's go ahead and select our dough, and I'm going to turn it into a flip fluid from object. Now that creates these particles here that represent the shape of the can, and if we rewind and play our timeline at this point, you'll see that they behave just like a regular old blob of water. What we have to do is make them viscous. So with nothing selected, I have my selection tool from the toolbar here, but I have nothing selected. I want to go ahead and click Make Viscous. Now I'm prompted to select the flip objects that I want to make viscous. And I can select those. Here I want these particles here. This is my flip object. And you'll see that I have that selected here inside the Autodop network. Press Enter to complete. And I'm told that I can control the viscosity of my fluid globally with the Volume Motion Viscosity tab of the Flip Solver node. We say, OK, that's what I want to do. So I come over here to viscosity. See that my viscosity has already been enabled and all the parameters have been set up so that my fluid is ready to go. I'm going to lay this out just a little bit better here. I'm tapping L on the keyboard. That'll just sort of fan things out so that I can see the entire network. Now let's rewind and hit play. Well, we can kind of see that we're getting something happening like what we want. It'd be better if we could see it with a surface. So let's go ahead and come over here to our visualization node on our flip fluid object and turn on our guides and our surface. Now, one bad thing about surface is we know that unless we calculate that very first frame, we're not going to be able to see the surface. We also have to be stuck inside of our Autodop network to see it. Well, there's a couple of little workarounds for that. Let's jump back out to object level. Now the dough fluid and dough fluid interior, up to this point, we've mentioned that these fluid and fluid interior nodes are used primarily for rendering, and they are. Now with dough, we're not necessarily going to see through it into the inside of it past its shell, so we can really just turn off the fluid interior for now. The dough fluid, on the other hand, I can actually switch the render node from being the visualization data from DOPS, which is what this is, this node here, this DOP import, calls in the visualization information that's being created by the Autodop network, and that's what it's rendering into the viewport. Well, what I want to render into the viewport is the actual surface of the fluid that would be rendered. So I can click on this little node here, be sure that the render flag is all the way down, and now in my viewport I can actually see that blob of dough. Now it's blue, it doesn't matter, we know our biscuit dough is not going to be blue, but we can change that later whenever we go to start adding shaders and things of that nature. For right now, we're mainly concerned about the behavior of how it looks whenever it's cut. So let's play that back and see what we've got. Okay, well, we can see that the blade definitely has some effect on the dough. And the dough is sticking to the blade, that's kind of a neat little effect. But really, it's not cutting the dough, and the dough is almost melting immediately, like really hot, gross biscuit dough. So let's change those two things immediately. I have a suspicion that we don't have enough resolution inside of our fluid. So let's start there. We know that we can come over to the flip fluid object, and that we can change the particle separation to add more particles inside of this particular dough. So to do that, instead of using 0.1, let's use a 0.033. Now instantly we get a lot more particles in our scene. Let's rewind and see what that looks like. Well, it's a start, but I don't think it's viscous enough yet. So we're more like smearing the dough along the surface, and it's still sticking to the edge a little bit. Let's make our dough a lot more viscous. And we do that here on the Flip Solver node. Inside the Volume Motion, there is the Viscosity tab. And inside the Viscosity tab, we can crank this up. Let's crank it up to something crazy, like say 10,000. So now we've actually taken this viscosity, this fluid that was like water, and made it into something that's almost perfectly stiff. So we go to cut through it, and man, our knife is just not quite cutting through the dough. It's really just sort of making a blobby mess out of it. Well, one thing is that our collisions on our knife blade are not set up 100% correct. I remember we did this earlier when we were messing around with the pump, and we were using the pump to control the position of the fluid along the riverbank. The first thing that we did was change the river basin so that it wasn't using volume collisions, but that it was actually using the edges and points on the original geometry to define where the collision is. Again, this is actually covered in an Introduction to Collisions course that we have out on the website now. You should go check that out. So I'm not going to go fully into detail as to why and explain all of that right here, because it is explained inside that Introduction to Collisions and Houdini course. So check that one out if you haven't seen it yet. So now that we've changed our collisions and we've upped the resolution of our geometry, let's hit rewind and play back and see what we get. Our blade comes through, it cuts through the dough, it actually penetrates the dough, tears off a chunk, and it's left behind. So we actually are able to put enough viscosity onto a piece of fluid that we can actually get it to behave almost like two separate objects. Now these are two separate objects at this point. The particles have just been separated by distance enough that they are only meshing the individual sections of their own, area. So that's how we're able to cut dough with the use of viscosity. We're using the blade to separate the particles apart from each other enough that they actually get two separate skins. Now this is still a pretty low resolution version of this. You can see we don't have a lot of detail on where the knife comes through and cuts. But that detail is gained by working with the particle separation here that you have inside of your flip object. Now we've talked about this before as well. Now I went ahead and pumped up my particle separation pretty high and did a quick little render, and instead of making you guys wait for it to simulate the whole time, I'll just play back the video for you. So here's the video, and we'll go ahead and play you back the results. Now that was a pretty low particle separation. In fact, there were quite a few particles in this scene, and to actually finish out this simulation, it took me somewhere around 25 to 30 minutes. So it wasn't quite as quick as what we saw on the viewport just now where we were working, but it is a much higher resolution divide. You can actually see these lines here from the can added in these little divots, and you can actually see how the knife, as it slowly cuts away, leaves back these little chunks. Pause it right there. So you can see this little division, the stair-stepping that's happening, and this comes from when the dough separates itself from the blade. You can also tell that this edge shape is holding a lot better. Once it's cut, those particles almost fuse together because of the viscosity attribute and how high it is. So that rounds out how you cut dough in Houdini. That also rounds out this entire course. I hope all is well and work is good, and thank you for watching.